Thank you all for listening. My name is Murali Shankar. I work with the LCLS at Slack, along with various folks here. We have this thing called eLog that I'm going to talk about a little bit. This is principally the LCLS data management portal. Let me go to the next slide. Hopefully you guys can see this. And this is one of the principal user interfaces that our users and instrument scientists and control room personnel use during an experiment. So this is a web application. So it consists of a JavaScript heavy UI, which is talking to some web services in the backend using JSON over HTTPS. So the web services UI are built such that the UI completely uses the web services. There's nothing behind the scenes there. And the same API that the UI uses can also be used during scripting. And this is very helpful during automation. The eLog, or this data management portal per se, is used in multiple facilities at Slack. Of course, LCLS is the principal user. We also have our cryo-EM facility that uses this, and also our UED facility that uses this. All these facilities, they're somewhat similar in sort of the data taking requirements, but they also have slightly different quirks to each. So we have to satisfy all of these. So the reason I say that is that because of this, the infrastructure is built sort of in a composable and extensible fashion. What I mean by that is we have lots of little components that solve some of the more unique features for each facility. And anytime we want to add a new feature that's specific to a facility, we usually write a new component that we plug into the infrastructure. So not all components are deployed on all facilities. And I have a couple of examples of how we deal with these differing requirements. The eLog application, focuses pretty heavily on the notion of an experiment. And most entities in the system are scoped within an experiment, and we'll expand on this in a bit. So this is really a multi-tenancy problem, with the experiment being the tenant, as it were. And finally, for this talk, I will mostly show where I will be mostly focused on demoing various features, various high-level features, so that you folks can visualize how we use this system and how it is used, especially in remote operations. I have a couple of technical slides, but the intent for this presentation is mostly to show you how the eLog is used. So there'll be some examples and things like that. And since this is mostly a demo over Zoom, I'll be switching between various tabs in the Google Chrome that you can see. If hopefully this is not too jarring, please let me know if otherwise. So just a brief introduction on the various sort of data management entities. So the eLog is focused very heavily on this notion of an experiment. Experiment is a bunch of collaborators who come to LCLS or cryo-EM to take data using various instruments. An instrument is typically a set of detectors. Sometimes you have more than one instance of an instrument. These are called stations. So you could have, two copies of the same set of detectors, and we will sometimes run experiments on both instances or both stations. In LCLS, and pretty much in most places, data taking is done in units of runs. The run is a fundamental unit of data taking. The eLog talks principally in terms of runs within an experiment. The analysis for the data is also done in the context or in the granularity of runs. So runs are a fundamental concept. Data is typically stored in files on the file system. The DAC usually stores detector data in fairly large files. And these are registered in the eLog. So the eLog has a file catalog, and that's a source of truth for that. In addition to the data being stored in the various data files, various detector data files, there's also all these small epics variables. These are typically things like vacuum pressure or beam energy or various small epics things. Those are uploaded to the eLog as run parameters. And they are displayed in the system using run tables, and I have a few examples of that. There is a logbook that's sort of heavily used within LCLS and UED, not so used in cryo-EM. And this is where you do human readable notes as to the progress of the experiment. You can attach snapshots or screenshots or tabular data or various other things, and you can do follow-up and things like that. So it's a very typical lab notebook. In addition, we have, hang on, we have the ability to automatically trigger analysis jobs in the workflow. And so based on data management events, we typically talk to Slurm, and based on some data management event, we can kick off a Slurm task or a sequence of Slurm tasks or a Airflow workflow tasks. And as part of those workflow tasks, you can update progress bar counters. So you can say, this is the hit rate, or this is the number of events I've found, and those will be propagated through the plumbing we have into the UI, and you can see that in the UI, and hopefully I have time to show you that. And finally, we have some businessy things like feedback and operations and reporting and things of that nature. So this is sort of the technical architecture. The eLog, like I said, is fundamentally a browser application. It's JavaScript heavy. It talks to a bunch of web services with JSON over HTTPS. There's a proxy that provides authentication. The web services, there's many of them. There's and they all talk to a MongoDB backend, and they publish messages onto a Kafka message bus. And there's a whole slew of other web services and other services that sit around the message, sit around the Kafka bus. And this is how we do that composable, extensible infrastructure. Typically, each facility has its own specific DAC. And this DAC also uses the same web services API to start runs, register files, and things of that nature. One more technical slide. Everything in the system this is very document based. Everything in the system is a document. Data is stored as documents in MongoDB. So for example, for runs, we will have a run document. For files, we will have a file document. Data is also published as documents on Kafka. So whenever we publish a message, for example, whenever we publish a file message, you take the file document, wrap it in an envelope. The envelope typically has some meta information, basically what kind of operation, who did it, when did they do it, whatever, and then you publish it onto Kafka. All the data and all the API calls are scoped to an experiment. So with a few exceptions, everything is in the context of an experiment. Each experiment is also associated with an instrument. And this lets us do some higher level things like instrument level permissions or instrument level run tables, or in Cryo, which uses this extensively, is instrument level sample definitions and things of that nature. So I will show a little bit of that later. We do use this in multiple facilities, LCLS, CryoM, and UED. Each of these has differing requirements. A good example is for LCLS, we use LDAP groups for file permissions for each experiment. So what that means is for each experiment, we create an LDAP group in our LDAP. Every collaborator that is added or removed from the experiment using the collaborators tab is automatically mirrored in the LDAP instance using a separate service. This is not done in other facilities. This is only very LCLS specific. So what we do is we break this down into a separate service that listens to experiment messages on Kafka. Anytime that experiment message comes through, it compares the LDAP membership with the collaborator list and tries to keep them in sync. So, and this is only deployed in LCLS. And this is sort of a generic pattern we use to kind of do this facility specific feature. And we try to minimize as much as we can the if facility equals LCLS kind of code. There's still, but we should try and make those into kind of extract them into separate components. Every facility starts with a DAC, and it has its own DAC. The API for the DAC typically has a notion of a current experiment. Each DAC knows unambiguously which instrument and station it is, Therefore, it makes a call to the eLog to say, okay, this is me, what's my current experiment? So there is a notion of the current experiment on the eLog side. Each experiment also has a notion of a current run. For LCLS and UED, we use auto increment numbers for this. But for cryo, which has a slightly looser integration with the microscope software, the run ID is actually some microscope specific string entity that cryo uses. So there's some variation there. For each run, the DAC typically starts a run and then gets the run number, of course. And then it takes data, and for each data is usually multiple files. Each registers each of these files with the eLog in using a register file command. Some of the epics variables are also, these are also stored in the data files, but some of them for UI purposes so that people can see what's going on are also uploaded as run parameters. They're uploaded in bulk. And for those of you familiar with epics, the description fields for these are also uploaded as run parameter descriptions so that you get tooltips and help in the UI. And then once the run is done, there is typically an end run call that closes, that says this run is over and we are off to the next run. So there are two separate sections of the eLog. The main section is the user section, which we'll focus on for the rest of the talk, but there is also an operator section, which is targeted at instrument operators and beamline scientists and so on. And let me show you one of these. I do believe this is the LCLS operator screen. Hopefully you guys can see it. If not, let me know. But you can see this is where you create experiments. This is where you create instruments. We do have global role-based controls that are involved and do this here. You can control instrument-specific roles here. And there's some reporting, you can do, we maintain a small amount of reports and you can kind of see how many runs and last runs and things like that. So there's some reporting there. Let me go back to my slides. That's mostly all I'll show about the operator screen. But then the main part is the user screen. And the user side has two pieces. One is where you select an experiment. So this is all the experiments that I can see. And there is an eLog experiment. There is an eLog per experiment. And we can go to one of these guys and you can see this, for instance. So this is an MSc commissioning experiment, and you guys can see there's one, and there's a bunch of tabs on the top, and we'll go to that in a little bit. So every experiment, you have tabs for each data management function. So some more technical stuff. The updates to runs, run parameters, files are all pushed through a WebSocket connection from the backend to the UI. So there is no polling. That's mostly what I wanted to say. The pages should be responsive, and most of these pages should have infinite scroll. And there should be zoom information for most of these experiments. I think MEC. Do you guys see this? And I believe this one should have zoom information, and we put some. You can put any name value pairs as part of an experiment, and we use zoom information and Slack information. Hang on, this is getting in the way. All right, and you can see that there. You can have custom entry pages for each experiment, facility-specific entry pages for each experiment. The LCLS one has Slack channels and experiment setup information. The cryo side has mostly PI information and sample summary. Let's go to the main part. We're running a little short here. So I have the first thing is run parameters are exposed to the users as run tables. And I think you guys can see a run table now. Please let me know if you have it. So this is tabular representations of run parameters. This is one of the most heavily used parts of the eLog in the LCLS side, at least, and even in the cryo side. So they have various run tables. You can define whatever run table you want. You just click on this plus button, and then you whatever fields, just click on it. and they can choose a bunch of fields, create definition. You can say, you can add electron beam parameters or vacuum parameters or whatever. There is a categorization of run parameters that is facility specific. Let me just close that. But this, it's a reasonably responsive UI, and it has infinite scroll, so you can keep scrolling down. Each time you go down, it goes there. You can see which detectors are being used. In a particular experiment, there is some data production run tables. This data production run table is interesting because it's a system-wide run table. So you can create a run table and make it available to all experiments in the system. So all the run parameters that are uploaded, you can kind of see them in a tabular fashion over here. Let me see if I can go to the cryo side to show you the maybe this guy. All right. So you can also show simple charts, scatter plots, and strip lines for the run parameter data. So for example, this is a cryo time series that they use fairly frequently. So you can do simple charts. You can also do something called pivot tables and things like that. So there's a fair amount of ways in which run parameters are rendered to the system. So that's mostly all I had to say about that. Another big part of the eLog is the file manager. Data is typically stored in files. There's two pieces to the file data. There is a file catalog, which is typically stored in the eLog, but actually there's also the actual management of the files themselves, for which we use external software, typically Rucio or iRods, that manage these files. What I mean by that is, storing the files on tape, storing multiple copies of the files, moving files from one point to the other. This is all done with software that's driven off Rucio and iRod. So there is some integration there. So let me show you the file manager. Commissioning. So you can see the file manager. Each run has a list of files, and you can restore and restore and update files. The update should really be refreshed. So files can be deleted behind the scenes. The actual source of truth for the file information, whether a file is actually present at a particular location or not, is really the file system. The eLog just can only tell you, as of some point in time, I knew this file was there. So you can kind of click on the update button and get the latest status of the existence of files. If a file is not present, you can actually click on the restore button, and then it'll go to Rucio or iRods and restore it back from tape. So there is that integration in there. There are these things called days, that file registration events on Kafka, and then they use a queue to move data from one location to the other. And these publish file migration messages once the files are actually moved. And actually those file migration messages can be used to trigger workflows, and we will show that a little bit. We also have this notion of a sample. A sample is really a logical run group. That is, a group of runs can belong to a sample. LCLS uses samples a little bit, but Cryo and UED use samples quite extensively. So I will show that to you. There is this notion of a current sample. So whenever a new run is taken, you automatically associate it with a current sample if it is present. The current sample can also act as a filter in the UI, and you can also attach parameters to a sample. You can kind of say, this is how the sample was prepared. This is, this is all the steps I took. This is, various parameters for the sample, some of which will be numbers, some of which will be enumerations and things like that. Cryo uses this quite extensively, where they have an instrument-specific sample definition, where you can say, for this instrument, I want the user to enter these sample parameters, and we don't let you make a sample active until those parameters are present. So we have that too. Let me see if I can show you a cryo experiment with samples. And you can see these are all the samples. And for example, I'll click on this info button, and you can see all the various parameters that we use for this particular instrument in a sample. And over here, you have a notion of this is the current sample, but you can also switch the UI for the current sample to show other samples. And we do have that in there. So again, I'm running short on time. So a heavily used part of the system is this logbook. And let me see which one I had for that. Commissioning, that's fine. So this is a typical logbook. It's usually human generated content. You can upload attachments. So for example, you'll have some kind of a screenshot. Let me actually go back to my slides and show you this next screen, and I'll come back to this. This is an external component that we have called a grubber, which is really a small Python application that is used, that is primarily used to post stuff to the eLog. So, people will write a comment and then click on the grab button, which does a X or screenshot grab, and then you point to a window or you point to the entire screen, and that is uploaded to the eLog as an attachment. And let's go back to my commissioning experiment, if I can find it. There you go. So we also add entries when a run is started, and you can kind of see all the various run parameters, for instance. Let me try to expand this guy. Maybe and you can see all the various run parameters that are uploaded in the DAC. And let me actually switch to another experiment, and I'll show you another feature that's reasonably heavily used, which is this tagging. Not this guy, sorry. This guy. Can you see my system? And these little over here, you have the pulse laser system and things like that. So you can categorize or tag log statements using these your custom tags, and then you can in the screen select by a tag. For example, I can say, show me all the long pulse laser system entries, and there you go, and you can do all of that stuff. This tagging scheme is pretty heavily used, actually. This is also used to categorize runs into dark runs and other things that are actually used during analysis, for instance. So let me go back to my slides here. So attachments are actually stored in the MongoDB database itself, but they can also be archived elsewhere. Once you're done with an experiment, after it's been a certain number of years, if you want to store it off into like an external system, you can do that, because these attachments never change, right? So that's another thing. Nothing in the logbook can be deleted. You can change things. I mean, you can add new entries to override other entries, but you can never change this. You can also attach tables and HTML quantities to a log entry. There's full text support for full text search, and you can automatically, let me go back to my commissioning experiment, and you have these buttons here, and you can kind of say, okay, I want to register so that I get automatically emails whenever a new log statement is being made. You can do that. We also have this notion of an instrument log. So let me go back to my slides and show you in here. So when you submit each instrument has its own instrument log. And when you submit the log statement, you can actually submit it both to the experiment log and to the instrument log. This is to notify the instrument scientist of some problem, feature, issue, whatever. So you're basically making two statements. You're making one in the experiment and one in the instrument log. And a lot of folks, at least the instrument scientists and controls folks, whenever they log in, they just look at the instrument log to see what happened on that instrument. Let me go back to my log here. You can do follow-ups and things like that. We also have Slack integration, which I don't know that I have time to show you, but anytime we create a Slack channel in a specific workspace, and then anytime a log statement is made in the experiment, that gets automatically propagated out to the Slack channel. There's some Jira integration, and that's pretty heavily used. Okay. We have the ability to trigger analysis jobs as part of data management events. And these are typically the start, end, or the end of a run. Also, complicated triggers like the first file for a run was successfully transferred. Okay, kick off an analysis job. Or maybe all files for the run are successfully transferred, so kick off an analysis job. There is also this other thing where you can kick off an analysis job when a run parameter achieves a particular value. And this you can use for simple sequencing. You can say, so run this job after that run job has completed, after that other job has completed. When that other job completes, you can set a run parameter value and then use that as the trigger for the next job. In fact, one of the experiments I'm going to show you has this. There are integrations with Slurm, LSF, and we also support the ability to trigger jobs at NERSC. So, whenever we have the ability to transfer files all the way to NERSC, and then when the files have been transferred, you can automatically kick off an analysis job at using NERSC Cori Slurm deployment using their SF API. And the typical task control actions are, you view the log file, you kill the job, and so on and so forth. Let me show you two of these guys. And I'll try to see if, I think we have time to, so this is Rick's.
It would be good if you could come to an end in the next 5 minutes.
Yeah, I think I can do that. So this is all the workflows for a particular, for Rick's experiment that's recent. So you can see all the various jobs that were run. And over here, you see on the right-hand side, you see these progress bar events. And I'll show you one of these in a minute. And this is where you can publish updates from the job, from the analysis job. You publish updates saying, this is the hit count and so on and so forth. These are progress bar, % done kind of updates. And they show up in the UI. And hopefully I have time to show you that as well. Let me go back to my slides. And that's largely all I had for this workflow. Let me see, I think I have time to show you this in action, but maybe I won't do it because there's only 4 minutes. And as part of your analysis job, you can generate summaries. You can generate one or more HTML summaries, and let me show you some of those. And then these are summaries that you should display in, these are just HTML files and MECLU 9418. Let me try that. Oops. I don't know where, let me just give me 1 second.
Murali, I think you can just show the pedestal plot, and if people care more about details about fancy, you there.
Yeah. So I'm going to try to show them the pedestal plot for MECLU 9418. So these are summaries. These are actually, it'll take some time for it to load, but these are actually HTML files that are generated as part of automatic analysis jobs. And they get stored on the file system in sort of the results folder. And then you can see these in the eLog, and then you can look at them. And they're actually quite complicated HTML pages with tabs and things like that. And hopefully this has enough bandwidth to download it in the time that I have left, but maybe it doesn't.
There's like a few megapixel images.
There you go.
So, okay.
There you go. You have histograms and detector images, and yeah, hopefully you guys can see this. I'm just going to cycle through those. And there's also data quality stuff and pedestal stuff. So we have more and more of this automatic analysis jobs that are triggered automatically on data management events that generate these summary files. And we're getting to a stage where people are just mostly looking for these summary files. That's what they're looking at. Let me go back to my slides. I just have a few more. And then I'll quickly run through them. So we have the ability to do feedback forms and reporting. These are facility-specific feedback forms. How did the experiment go? Did something break? Did something, please don't do this again, kind of feedback forms. And what we do is we take this information and then push it to Tableau using an API. And in Tableau, there's, at the end of a run period, at the end of the year, basically, all the management folks look at the Tableau reports and say, okay, how successful were we? How many problems did we encounter and things like that. I'm almost out of time here. So there is facility-specific help, and there is API documentation that is also available as part of the eLog itself. The collaborators, we have a tab to manage the collaborator list. Authentication is external SSO. For now, we use a WebAuth, but then we're hoping to transition to OpenID Connect or SAML. Authorization is role-based access control. There is a per experiment specific role-based access control, and there's also site-wide access control. In LCLS, access control is based on access control lists on the file system. So there is like I said, an LDAP group that is generated per experiment. In Cryo, authorization is handled differently. Deployment. In LCLS, we deploy it on raw Linux servers, but on Cryo, we deploy the whole thing on a Kubernetes cluster. So that's there too. Future directions, we want to do tighter integration with Jupyter Hub, see if we can embed Jupyter Hub within the eLog. So when you go to the eLog, you will get a Jupyter Hub entry point into the Jupyter Hub for that experiment. We're pushing actively to move to containers for run processing, for analysis. And also we're trying to see if we can get federated authentication in the picture. I think I'm almost out of time, so I'm going to stop there for questions.